We will continue our session with cone, but this time we want to look at the surface area of a cone. Now we have a cone over here, alright. Okay, it has a slant height of L and a radius which is measured from the center of this circle, which is the base, to its edge, and let's say we call this length R. Now the total surface of a cone is actually made up of two components. One component, which is the base area, which is a circular base, this area, and the curved surface area of the cone, very much like the party hat that you usually wear on top of your head during a birthday party. So the base area, surface area, is actually based on a formula pi r square. Pi is this symbol, which I will explain later on using an example. R is the radius, which is measured over here from the center all the way to the edge, right, square. And the curved surface area is actually pi r L. Again, R is a radius and L is the slant height. Okay. However, sometimes in the question, your slant height, which is L, is not given to you. Right. Instead, the question may give you the actual height of the cone, which is actually measured from its base all the way up to its tip, right? Which in this case I will represent using the letter H. So what do I do? Well, if the slant height is not given to me, right, I will need to find it. Okay, and if you look very closely, you will see that, okay, this H is one side, R is another side, and L is actually a triangle, right? And it is right angle. So I can use my Pythagoras theorem. So based on my Pythagoras theorem, the L square is actually the sum of the two sides, H square plus R square. So this is actually created from the Pythagoras theorem. Now if I solve this, then of course if I want to get rid of the square in the L, I will square root this portion, which is the right portion of the equation, right? And once I have this answer, which is L, I can actually take this L answer and place it into my curved surface area formula. Alright. Now I know cone is a little bit more tricky, right? But don't give up, keep practicing, okay? And I'm sure you'll be able to do fine.